Okay, so taking a look at the rest of this, we're talking about those things that we don't know, probably cannot know, and I guess what better place to end, because, as I say, that's the most comprehensive kind of knowledge of all, right? It presses against the things that we simply cannot tell for certain. A couple of other things that we can kind of think about from scientific or a philosophical standpoint, but we're presented with some unanswerable questions. For instance, how do we understand the fundamental structure of space and time? Here's another one of those questions that provides all sorts of speculation, but nothing really definite. You take space, for instance. We know what space is composed of in the sense of its dimensions, right? The 3 dimensions. And we also know that space is full of a bunch of stuff like planets and stars and galaxies, all of it made up of these smaller things. But what really is the foundation, the groundwork of a space itself? Science doesn't have really an answer to that question. There are different theories out there, radical theories like string theory, loop quantum gravity, but they're not definite in any sense. They're just speculative. So too, the question of time. Talk about something abstract in that sense. What exactly is time? We understand basically how it works, right? Works through this idea of cause and effect. One thing causes another thing to happen. And also that all-important principle of irreversibility, the arrow of time. You cannot repeat the past. It's just marching forward all the time. And we can certainly measure time if we want to. If we have a nice kind of cyclical process, like the Earth revolving around the sun, well, that allows us to kind of keep track of time. But what really is the fundamental essence of time? What causes it to exist? Again, science doesn't really know. In fact, scientists speculate to a degree that time doesn't exist as such. We just have the illusion of it existing because of all these events that are occurring. Something else to really speak to this idea of how opaque and kind of impenetrable our surroundings might actually be. Said, the elementary particles and fundamental forces contribute to the formation of stars, planets, life forms, and people, yet science indicates that altogether they only make up about 5% of the total energy and matter in the universe. So in other words, what we're detecting amounts to 5% of the total energy and matter in the universe. The remaining 95% exists in the form of a dark matter and a dark energy. I mentioned dark energy previously. That is linked to the ongoing expansion of the universe. So they say it's being powered by dark energy. We don't understand what it is, though. It just speculate that it does in fact exist. And dark matter is something else as well. It's a form of matter that we can only very loosely detect in a kind of indirect way. They say that dark matter exists due to the existence of galaxies. The basic idea, I won't get into it in any depth, but the basic idea is that spiral galaxies would not be able to maintain their shape. They would not hold themselves together without an abundance of dark matter within them. And we think about that for a moment. Well, dark matter is a kind of a form of matter that we can, as I say, loosely detect, yet we can't see it directly. We can't interact with it directly. And we stop and think about that for a moment. There's this idea of why should we be able to detect and interact with everything in the universe? We're just these kind of surface-dwelling creatures on the planet Earth. We're kind of wired to deal with our immediate surroundings and our environment. We deal with gravity and electromagnetism. There's probably all sorts of stuff out there that's simply beyond the powers of our detection, our perception, comprehension. All sorts of different worlds might be unfolding right now that we're just incapable of seeing. We're not designed to interact with this stuff. Something else as well, the anthropic principle. Here's a kind of very interesting idea, concept, which we can grasp, but nonetheless cannot necessarily explain with any depth or certainty. The anthropic principle states that the universe must have evolved in such a way as to make an observer like humanity possible. This statement is both obvious and yet puzzling. It's obvious because as soon as you say it, basically saying, well, you know, the universe is this kind of thing which is capable of producing a species like us, we say, well, yeah, it's obvious because here we are. that has to have happened. So the universe, from the very beginning, has to have had the potential to create not just stars and planets, but a being like us, a being that is kind of capable of reflecting on existence itself, capable of contemplating the cosmos in an in-depth way. So as I say, it's a kind of obvious assertion to make, and yet it's also a very puzzling development because it's only a string of remarkable coincidences that is enabled for the existence of humanity. You think about the history of the Earth as a whole. I said this before, we're a rare species. And if you look at evolutionary history, there probably was no guarantee that an animal like humanity would emerge. In fact, it's probably an unlikely thing to have happened. But it goes even deeper than that. If you go back to the very beginning of the universe, the emergence of the elementary particles and the fundamental forces, it is only due to the specific ways they interact with one another that any life is even possible. If the kind of properties of the elementary particles had been slightly different, tweaked a little bit differently, no life ever could have formed in the universe. Would have been absolutely impossible. So if we look at it in that way, it's almost as though there's been this kind of fine tweaking or fine tuning that's been set up to ensure that life can actually flourish in the universe. It all makes it seem very kind of purposeful and meaningful to us. And yet, is it purposeful? Or is it really just a bunch of random stuff that's happened? That there was no reason to it. We just happen to be in a universe where life is possible. It's kind of like winning the lottery, right? When you look at the numbers on the ticket, and if you see that your numbers match exactly the numbers on the TV screen, you say, oh, that's incredible. That's meaningful. That's purposeful. Oh, no, it's random. Right? It's just a random event. It just happened to sync up. And perhaps that's the case for the existence of humanity and life as a whole. A random sequence of events which seems very purposeful to us because it's like we won the lottery or something. Point that was brought up previously, the question about the difference between the Andromeda Galaxy and the Milky Way Galaxy. Well, from a distance, not a lot. And so, too, when we look at the cosmos as a whole. There you see the Hubble Telescope Extreme, a deep field view of the cosmos showing various galaxies. Those are not stars. Those are galaxies, so collections of different stars. And part of what is really fascinating about that image is that it's looking at a very small section of the sky. It's like looking through a straw and seeing an incredible abundance out there. This is where they're coming to the conclusion that there might be something like 2 trillion galaxies in the universe, because if there are that many in just a tiny section of sky, then, well, there must be all around us right now. This is what we see. Galaxies which, yes, can appear different in terms of their structure. Some are closer to us, some are dimmer, some brighter, some younger, some older, but nonetheless, it looks fairly uniform, and that's the story of the universe as a whole. It's a uniform place. It consists of the same things everywhere we look. Everywhere we would look, we would expect to find galaxies. All those galaxies have stars. All the stars have planets as well. And thus we'd expect to find living organisms as well. So there isn't really a kind of different form of being anywhere in the universe. It's all very uniform and homogeneous. But nonetheless, it's a uniformity that conceals an enormous diversity. We just can't see the stuff up close. It's kind of like going out at night, and if the skies are actually clear, if there are no clouds, you look up at the sky and see all the stars above you, and you're seeing uniformity, right? They all just kind of look the same, some brighter, some dimmer, but nonetheless, that's what you're looking at. But again, if you could zoom in, imagine the diversity that you would actually see, especially if you found another habitable planet with all of its wildlife, its plant life, all those different things. You would see an extraordinary amount of diversity up close. So it's that kind of mixture of uniformity and diversity. So kind of looking beyond our kind of simple kind of surface existence on the Earth, we look outwards ever further, and there are all sorts of things we see. You can imagine these things as being, on the one hand, so much larger than us in a kind of a daunting way, almost like they belong to the sublime. And yet one important point to keep in mind is that humans are products and reflections of the universe. So everything out there is linked to us. We're all products and reflections of the things that exist in the deepest regions of space. And I think we can find some of these symbolic connections, these symbolic links, if we sort of look at it in the right way. You see a spiral galaxy, spectacular image of the spiral galaxy with that telltale cyclical shape to it. It is now generally thought that galaxies spiral around supermassive black holes. Not sure if that is one of those things that we could ever prove for certain. It's just a theory. It's basically the idea that at the center of these galaxies you have a massive black hole. A black hole is a kind of a very dense region of space-time which exerts a tremendous gravitational pull, so strong that no light can ever escape from it. And in case you're wondering, there is indeed a supermassive black hole at the center of the Milky Way galaxy. It's known as Sagittarius A star. I like this just for the symbolic connection to it. Think about the idea of the center of existence. Get to the heart of things, to the very center. Galaxy has a kind of symbolic center, a kind of inner essence to it, the hub right at the middle. And when we look into the kind of the heart of the galaxy, its very central point, what do we see? Nothing. Just opaque. We get no information from it. It's this kind of place of mystery and the unknown, because a black hole yields no information, tells us nothing about it. It's kind of keeping all of its secrets to itself, because no light can escape from its surface, and if there's no light, we can't learn anything about it. So I think a kind of symbolic idea about kind of our quest to understand the kind of inner essence of existence. Quasar. This is another kind of interesting cosmic phenomenon. There you have a Hubble image of a quasar, which are linked to black holes. There you see gas clouds being sucked towards black holes collide together in a swirling superheated maelstrom, emitting gigantic quantities of energy before disappearing forever into the black hole. Mammoth jets of radiation and matter are ejected over distances the size of galaxies. So, as I say, black holes exert a tremendous gravitational pull. You don't actually see anything inside of the black hole, but you certainly see their effects on their surrounding as all of this stuff, this space gas and space dust, is sucked down towards the heart of the black hole. And as it kind of rushes down towards its final end, towards nothingness, as far as we're concerned, because we don't know what happens to it once it passes the event horizon, as it kind of rushes down, it heats up through friction and emits these tremendous amounts of energy, sending this luminous glow across the cosmos. I like that as a symbolic idea as well, burning up as it kind of plunges down forever to its final end. How luminous? Well, try up to 4 trillion times brighter than our own sun. That's how bright quasars can be. There you see quasar 3C273, typical imaginative name for an object in the sky. Cosmologists are notorious for coming up with these very technical names. Captured on the Hubble telescope, I think that is the closest quasar to us, and that's the brightest one we can see. There you see its tremendous glow, as I say, and an incredible luminosity, and the proof of which is that that thing is 2.5 billion light years away from us, and yet we're still able to see it. We talk about time travel. This to me is time travel. We're looking at something as it existed 2.5 billion years ago, before the dinosaurs, certainly before us, before there was anything like complex life, even on the planet Earth, and that's something that we're looking at in the past right there.
Excuse me, sir.
Yeah, question.
Will we simply call it a star or what?
Sorry, say that again?
I mean, the quasar, so long as we can see, will we simply call it a star?
No, it is not a star. Yeah, it's a good question. A quasar is an object that can contribute to the formation of stars, but stars are much smaller and much dimmer. Yeah. Interesting developments in cosmology. The James Webb Telescope you might have heard about, is the largest space telescope ever constructed. There you see it in its works, and it was launched in December of 2021. Operational right now, so if you Google James Webb Telescope images, you'll see some of the images that this telescope is capturing for us right now. And I won't get into its entire backstory of endless delays and cost overruns, which is the typical story for this object. But nonetheless, finally providing us with some incredible images, has a very large sun shield, among other things, to block the light from our sun to see into the deep regions of space. And I'll show you some of the images that this telescope has come up with. Well, here's one, for instance, the image of Glass Z13, a galaxy that dates back to the earliest stages of the universe. Again, remarkable, the things that we can see over long distances into the very deep past of the universe. We are looking at this galaxy as it existed approximately 13.5 billion years ago, captured there through infrared light. So that's kind of closer to the origins of the universe. And who knows what happened in that particular galaxy? All the stars that existed, planets that existed, species, organisms, life forms, who knows? It's kind of interesting to think about the fate of this thing, because when you think about the present moment, well, its fate has run an entire cycle, entire circuit, even though we're looking at it when it was just in its early stages, its formation. Think about the search for light, and that's exactly what we're looking for when we're pointing our telescopes up at the sky. And here's another one of these kinds of symbolic connections that I like, because it kind of links us to ourselves and sort of speaks to this link between humans and the wider cosmos. As I said, we can't see into a black hole because it yields no light. Nonetheless, you look up at the night sky and you see all the stars out there. There you have these points of light, and they're telling you something. They're showing you that something exists out there. There's this kind of idea of being connected to something that you're never going to see up close, can't necessarily learn anything about it in any particular detail, but nonetheless is a signal of something existing out there. In literature, philosophy, and film, human consciousness is often compared to light. That takes us back into the Greek tradition. Plato, for one, most famously came up with this idea of the sun as representing human knowledge. And Yoda, another philosopher as well, speaking about the kind of idea of human beings as being luminous beings, not just this crude matter. And I think that speaks to the duality of us as a species. On the one hand, we are, of course, just crude matter, these surface-dwelling mammals scurrying around on this planet who can maybe travel as far as the moon or perhaps as far as Mars. And we know that we're just kind of caught up in the flux and cycle of evolutionary history on the Earth and are really not special at all when you get down to it. And most of our concerns are just typical animalistic concerns, just dressed up in a big way. I mean, that kind of describes human civilization in a way. And yet human consciousness, right, the kind of the light, the luminosity, is a fascinating thing because it extends so far beyond us. It kind of presses against the very limits of the universe. Hence the reason that we can see over such enormous distances and understand what we're looking at. It's a kind of connection between the most distant objects and human thought and human perception. So kind of strange duality of us as a being, such a small creature, and yet nonetheless with faculties of consciousness that are so extensive in their scope and their reach. You see some antenna galaxies, a pair of colliding galaxies located over 45 million light years away. We talk about some things that are going to happen on the cosmic scale in the future, long after we're gone. In fact, after the planet Earth might well be gone. Scientists expect that our galaxy, the Milky Way, will collide with our closest neighbor, the Andromeda Galaxy, in about 4.5 billion years. Now, collide is a little bit of a loose term there because it's very unlikely that anything are physically going to run into each other because the distances between the stars are so great, but they nonetheless will interact with one another. And here's an event that will happen at some point in the deep future of time. I would say that thinking about these things, it makes us pause a little bit and consider our legacy vis-a-vis existence as a whole? What exactly is going to be our impact on the wider universe? What kind of influence are we going to have on the cosmos as a whole? Well, none, probably, when you get down to it, right? Because we're just this small creature on the surface of this planet, and if you want to look at it from a particular point of view, you'd say, well, we're just like this bacteria scurrying around on a rock, right? Just here for a moment, then it's gone. And that's kind of the fate of humanity in that kind of purely materialistic sense. And yet, on the other hand, I think our kind of awareness or our consciousness does take us into some kind of interesting questions which make us aware not only of our fate relative to the universe, but also our place within the wider sweep of existence. There you see a Hubble image of the Cartwheel galaxy. That's a small galaxy passing through a larger one. Here's the question that I raised previously. What preceded the Big Bang? Now, go on the basis that the universe had a particular moment of origin 13.8 billion years ago. Okay, so what came before it? Well, as I say, just a speculative question, but I would say that the commonest response that you'd get from a cosmologist is that we actually live in an infinite multiverse. Basically, what that means is that this is not the only universe that has ever existed. This is just one of many universes. In fact, this is one of a number of infinite universes. And so even though this universe might be finite and limited, finite in extent and duration, existence as a whole is just infinite. No point of beginning, no point of ending. It's just this endless cornucopia of different universes. Cannot verify that idea. We're never going to see another universe, but let's say for the sake of argument, if the multiverse is correct, then space and time may be infinite, meaning that a googol of years, that is 10 to the power of 100 years, would be but an instant of eternity. In fact, a googolplex of years, which is a one followed by a googol of years, a number so astronomical that there's not enough space in the entire universe to even write it out, would be but one instance. Now, a googol, and that is indeed where the name of the company comes from, although they spell it a little bit differently. I don't know if they spelled it differently by design or by accident, but anyway, there you see the actual number itself, a 1 with 100 zeros after it. So there you go. You can actually write that number out. That's a googol. Now, you imagine that in relation to the multiverse. If we say that space and time are infinite, then a googol of years has passed, can pass, will pass in the future. It's not just something that could happen, it's something that has to happen. It is inevitable that that ridiculous length of time will actually pass. In fact, we would say a googolplex of years will pass. Now, I said a googol is a 1 with 100 zeros after it. A googolplex is a 1 with this number of zeros after it. And as I said, if you were to start writing this number out just like that, 000, a googolplex, there is not enough space in the entire universe to write that number out. Never mind the planet, the solar system, the Milky Way galaxy. If you're just sitting there writing 000 after one another, you would run out of space in the universe before you'd completed that number, a googolplex. That's how ridiculously long that number is. And yet again, think about it in relation to the infinite multiverse. That amount of time, a googolplex of years, has to pass. It's inevitable that that ridiculous length of time will pass. In fact, that is just nothing relative to eternity, less than a drop in the entire ocean. And what different things will happen over that ridiculous stretch of time? How many different universes, how many different things in existence, just staggers the mind, just boggles the imagination in terms of all the things that we will never see and that we cannot possibly know. As I said, the multiverse is just a theory. There are different versions of the multiverse, which takes us into kind of different ideas about what may exist. We have the level 1 multiverse is a theory that states that space and time are infinite, so they're forever, no starting point, no ending point, and the laws of physics, constants, and elementary particles, fundamental forces, etc., are roughly the same everywhere. So it's just a kind of infinitude of the same stuff. Now, if you just picture that, it's just an endless array of galaxies, stars, planets, ad infinitum, on and on and on forever. So just stretching infinitely. Leads into some kind of curious implications because here is something that people who work on the multiverse have spoken about. Assuming that space extends forever in every direction and assuming that it contains the same basic ingredients, properties, and relationships ad infinitum, then you should actually start to turn up duplicate copies of the things that exist or have existed in the past. Think about that for a moment. The idea that it's like shuffling a deck of cards forever. You keep doing it, and eventually you start turning up the same combinations over and over again. If you imagine that the planet Earth is just a combination of different things, different stuff, and you can break it down into its tiniest constituent parts until you see it just as this jigsaw puzzle made up of tiny elementary particles at its smallest scale. Could this exact arrangement, could this exact structure recur across space and time? Absolutely could happen. Not only that, but it's inevitable that it would happen because it's infinite. So it doesn't matter how unlikely it is. It doesn't matter how many googolplexes upon googolplexes of years would have to pass until this incredibly unlikely event happens. It would have to happen because there's no endpoint to it. In fact, you yourself, the organism that you are, the creature that you are, if you just picture yourself, again, it's a collection of stuff on that purely material level, a collection of blood and bones and intestines and neurons, right? Break it down to that level of cells, molecules, elementary particles, all these things, right? Just a collection of quanta and energy buzzing around right now as a single structure. Has this particular structure, this organism, existed at some other point in the multiverse? Yes, definitely has happened. This creature that you are has existed at some other time, kind of like the proverbial identical snowflake, somewhere else on the opposite side of the multiverse. They've come up with some numbers. Again, these are mostly done in jest, but they say that the closest identical copy of any given individual should be located approximately 10 to the power, whatever number that is, right? Meters away, a very massive distance. So you may well have this kind of doppelganger, not a person that you're connected to on any causal level, right? But just the same thing somewhere else out there. It kind of makes it feel as though we're sort of these functionally immortal beings, right? That we always have to exist. It's a kind of spiritual idea, but the same applies to everything. It's like saying the planet Mars has to exist, right? This bottle has to exist because it exists right now. Yes, question.
It really makes sense because every single day new planets are discovered. Endlessly. Continuous discovery of planets, it keeps going and going.
Yeah.
So what is the ending?
Yeah, exactly. This is the idea of the infinite, and this is always something important to keep in mind, what the infinite actually entails when we say pure endlessness or something that actually has no functional endpoint to it. And the other theory, the level 2 multiverse, well, there is actually a different version of the multiverse here, which is just as valid, because as I say, we can't actually prove the multiverse theory, but the level 2 multiverse states that space and time should be infinite, but that the laws of physics, constants, elementary particles, and fundamental forces might vary from one universe to the next. And this theory opens the way to limitless possibilities of existence. In other words, existence might look quite different in other universes. Again, there's nothing that says we have to have gravity operating in this particular way. There's nothing really that says we have to have stars and planets. It's just the structure of our particular universe. Might be the case that there are enormous variations, different kinds of structures. How about different dimensions, for instance? All sorts of things. Again, if we think about this idea of the infinitude of the multiverse, it's the type of thing that seems not just possible, but inevitable that you start turning up these variations. I want to end with a point that I brought up at the beginning of the class, the idea of humans as being these finite beings connected to the infinite since the time of the cognitive revolution. Connected to the infinite, especially through our awareness of numbers, which are part of an infinite system, but also language. Remember, I mentioned that as well. The idea that there are no limits really to what we can depict, what we can represent. So we are creatures that are aware of the infinite, and perhaps that's the best indication of us being a kind of product and reflection of existence as a whole. Not just this universe, but the multiverse that stands beyond it, because that too might be an infinite realm. So, that's the end of the class. Thanks for the semester. Obviously, prepare, study for the tests coming up on Monday, and beyond that, enjoy the break, enjoy the time off.
Thank you very much.